Hello and welcome to this segment on college algebra where I will be talking about the distributive property. So first I want to review some key terms that will come up later on in these slides, the first being a coefficient. So a coefficient is a number in a term. So when you see this expression, you see this is a term and this is a term and this is a term. So the number 6 in this term is a coefficient, and so is the 9, and so is the 10, and the 5, and the -3. But then so the distributive property can help us write expressions in expanded and so now I'm going to use the distributive property to expand an expression. So here I'm going to distribute the outside number inside the parentheses. But before I do, I like to look inside the parentheses to see if I can simplify this first so that I can make this easier for myself. So I can see, for instance, that this is x to the 1 and y to the 1. And this term here is 4x to the 1 and y to the 1. So because these two terms share variables to the same power, I can add them together. And I'm going to go ahead and rewrite this problem as 5xy. And then I'm going to multiply inside. And that's going to give me 15xy. That's my answer. For this next one, I see that these two variables, or I'm sorry, these two terms are not like, so I cannot put them together because they have two separate variables. You can just imagine an imaginary one here. So I'm going to go ahead and multiply the 5 inside. I will distribute it inside this problem. So 5 times 6 is 30, and then you just put that x there, and then 5 times 1y is going to be 5y. Oh, hold on a second. It's going to be 5y. And that's my answer. For this last problem, I'm going to see again inside the parentheses. And again, I can see that there's x to the 1 here and x to the 1 over here. You could put an imaginary number here. And these are like terms, so I can put them together and rewrite the problem as 6x minus y. And then I just multiply inside with the 8. And that's going to give me 48x minus 8y. And there's your answer for that one. Before I move on, there's something that I didn't mention before, and that is when the sign on the outside, so let's say I had a -3 and inside the parentheses an x plus y. When you have a negative on the outside and you're distributing inside the parentheses, because this is a negative number, it's going to change the sign of the terms inside of the parentheses, and I'll show you what that means. So if I distribute this inside, because I'm multiplying by a -3, it's going to make our resulting product a negative. So it's going to be -3x, and then -3 times y is going to be -3y. And that would be the answer to this problem here. So this is a great opportunity to introduce the FOIL method, which is just a method to expand expressions. So this is not like the problems we have been working with. Here we have two sets of parentheses, which makes the problem a little more difficult, and it makes you wonder where you start first. So the FOIL is just an acronym, and each letter stands for something. I'll just write that out here. The F stands for first. O stands for outside. I stands for inside. And L stands for last. So if I were to show you that here in this problem, I would first say, okay, my first terms that I would multiply would be the 2x times the 6y. And then I would multiply the outside terms, which is the 2x times the x. And then the inside terms would be the 1 times, sorry, this is going to look a little confusing, the 6y. And then the last terms, I would multiply the 1 and the x. Sorry, this looks a little funky right now, but when I show you how to do it, it'll be a lot easier to see it. So let's go ahead and do that now. So the first ones that I would multiply first would be the 2x and the 6y. And after you find the products to each of these, to each multiplication, you're going to add them together. So the 2x times 6y is going to give you 12xy. Then you'd multiply the 2x times the x. Again, you're going to add it. It's going to be 2x squared. Then you're going to multiply the 1 times the 6y. It's going to be 6y. And then you're going to multiply the 1 times the x. And it's going to be x. And this here would be your answer. Again, no like terms, so this would just be my overall answer after I did all of that. So now I'm going to show you how to use the distributive property to factor an expression. So for this first one, what you're going to try to find is a factor that is common with each term. So we have 5, our coefficient, -5 as our second, and 25 as our third coefficient. And you could probably guess that the 5 is a common factor with all three. So I'm just going to take that out. And then I'm going to divide each one of these by 5. I'm going to divide each term by 5 to give us, in the parentheses, what's left over. So 5x3, x to the third, divided by 5 is going to give me x to the third. Then -5xy divided by 5 will be -xy. And then 25y squared divided by 5 is going to be +y squared. And that will be our answer for this one. Now, for this second one, you have 3 different terms where we can actually use a shortcut with the exception that the first term is an x squared. So I'm going to divide it into 2 separate parentheses. And you saw this back when we were using the FOIL method. And actually, if you did test out this answer at the end, you should be able to get our problem here. That's something you can test out if you'd like to. So I'm going to go ahead and put an x here and an x here. And then I'm going to ask myself, what adds to -10? And then what multiplies to +25? And this does take a little thought. You just have to go through some possible solutions. But for me, when I'm solving a problem like this, I look at the last term first because it gives me a pretty good idea of what numbers or what 2 numbers would give us 25. So for instance, 1 times 25, or 25 times 1, or 5 times 5. So it can't be, I already know it can't be 25 and 1 because it has to add to -10. So that's too high of a number. So it has to be 5 by 5. So I know that our factors are going to be 5 and 5. But now they have to add up to -10. So what adds up to -10? It can't be +5 and +5. That would be a +10. So they have to be negative. So that would be my answer. And if you want to simplify that even further, because this is a perfect square, I could just go ahead and square that one. Again, we're going to do that in this problem here, where I'm going to look at this first term, which is an x squared. So we're going to use that shortcut again and say, okay, what adds to -4 and then what multiplies to 3? Let's go ahead and put that in parentheses. Also, one shortcut that I've come to notice is that when the second term is negative and the third term is positive, that can already tell you that the factors are going to be negative. And that's what we saw in that second problem there. It's going to happen again in this one. So I'm going to put my x here, and that actually narrows it down a whole lot because I know that these are negative. Then that means that whatever these negative factors are has to add to -4 and has to multiply to 3. So they have to be negative because two negatives give you a positive, which it has to give you a +3. So what adds to -4? Well, I know that -1 and -3 give you -4. And then -1 times -3 is going to give you a +3. So then that is my answer right there. So now I'm going to let you try. So for this first side here, you are going to use the distributive property to expand the expression. And then over here on this side, you're going to use it to factor. So go ahead and pause the video and try it yourself now. So let's go through these problems one by one. For this first one, I hope you saw it. If not, that's fine. You can distribute the x into the problem, or you can look inside the parentheses and see what you can simplify first to make it easier for yourself. So you could have, if you wanted to, you could have added the x and the 10x together because they're like terms, and then added the -6xy to the -3xy, and that would have given you -9xy. And then after you distribute the x inside the parentheses, this would have been your answer. For this next one, there are no like terms, so you would just distribute the 2 inside to each term, and then that would be your answer for that one. And then here we're going to use the FOIL method to do the 8y times y, and then the 8y times -2, 1 times y, 1 times -2. And then this would have been your answer. Oh wait, sorry. This would have been your answer. You could add the -16y to the y because they're like terms, and that would have given you -15y. Over here on this side, when you factor, I can see that the common factor here would have been 4. So I took out the 4 and then divided each term by 4. That would have given me 4xy squared over here, -2xy over here, y over here, and then -1 over here. I hope you saw this one. This was a little tricky. I know I didn't add this to the last video because it was kind of meant to throw you off a bit. But if you wanted to rewrite it so that it was 3 terms like I had explained before, with the first term being an x squared, you could have put a placeholder, which is a 0x, and then you would have gotten your 3 terms and then went by it the same way. And you would have gotten something like this, where you would find terms that would add to 0 and then multiply to -9. And then this would have been your answer.